we are going to graph transformation of logarithmic functions, but specifically with a vertical stretch. So let's look at the graph of, we're going to graph f of x equals 3 log of x base 2. Now we're just going to walk through this and kind of think through the process and then actually graph it. Now if we think about the parent function, right, because we know a lot about parent functions, the parent function would be f of x equals the log of x base 2. So let's think about just what that means. Let's focus on the parent function. So if I do that, if I just focus on the parent function and say, okay, what about when x is 1? Well, what does that look like? Think about the work. Well, that means we would have some unknown equals the log of 1 base 2. Well, we can write that as an exponential, right? Base to the y equals 1. Well, 2 to the what power equals 1? Well, 2 to the 0 equals 1. So that means our y value would be 0. Okay? And the more logs you play with, the easier all of this gets. So now let's say, what about 2? Okay, so now I would say, well, we would have y equals the log of 2 base 2. Think of the same idea. Base raised to the y equals 2. So 2 to the what power is 2? Well, that's 2 to the first. Okay, great. So realistically, we want to think about powers of 2. So if we used 1/2, right? And some people, let me back up. Some people like to say, well, instead of x's, let's choose y. What if I want my y value to be 2? So I would say, okay, 2 equals the log of x base 2. So now we can say base raised over here equals x. So that means x is 4. So you can do it that way too, either way. What if I want my y value to be -1? -1 equals the log of x base 2. Sometimes it's easier if you go with the y, because then you're at least going to have nice answers. So now we have 2 to the -1st equals x, so x is 1/2. Okay, so now I have 4 points for my parent function. Now, that's all great and all, that we found these 4 points for the parent function, but that's just this part. So what does this 3 mean? Well, if we plug in a value for x, right, that's our input, our independent variable, and then we get an answer for the log of x. So log of x base 2 is right now equal to my y value in this table. So if you think about it, we're really taking the y value in this table and multiplying it by 3, because that's what this means. It means take whatever you have when you find the log of x base 2 and multiply it by 3. So we're going to add another line, and we're going to say this is basically 3 log of x base 2, or 3 times this y value. So 3 times 0 is 0. So that first ordered pair will be 1, 0. Then I take 3 times 1, which is 3, so that ordered pair will be 2, 3. And then I will take 3 times 2, which is 6, so I get 4, 6. And 3 times -1, which is -3. So that ordered pair will be 1/2, -3. So these are the 4 ordered pairs that are going to make up my graph. So when I go to my graph, I can say, okay, remember my 4 ordered pairs. I had 1, 0, 2, 3, 4, 6, and 1/2, -1. Okay, so let's plot them. 1, 0, 1, 0, 2, 3, 4, 6. Ooh, that's kind of off the screen up there. And 1/2, -1. So you can see when I connect all of these, right, and that goes that way, we still have a vertical asymptote at x equals 0, right? That's my vertical asymptote. We still have ourselves kind of this upward curve going left to right, but you can see how it's stretched, right? The normal logarithmic curve is more like this, right? It's kind of a sharper curve. It almost looks like a shapes are occurring to, like, struggling here. But now, if we multiply by 3, multiplying by a power greater than 1, it's going to be stretched out. So it's almost like you took each side of it and you just pulled. So instead of having this, like, curvature. It's more like a little slight arc, if you will. And that's the idea of graphing transformations of logarithmic functions with a vertical stretch.